So hello everybody. Thank you for joining this session. So I will present you how we kind of replicated the Python way of accessing data in the backend in the front end. So if you have any question in the end, feel free to scan the QR code and write down your questions. So yeah, I'll wait 2 seconds. All right. So, what was our motivation? So, I think, as you all know, the POS app is a little bit different than the other apps in Odoo. We're managing our GS and everything differently. So before we were using JSON files, JSON type to send data to the front end, and that caused some troubles because sometimes we weren't naming the fields as in the backend in the front end, and also in the end to have a more generic logic and not just fully custom. So for the loading data, the main goal was to prevent these JSON manipulations and to prevent processing data in the front end to create a link between the records for many-to-many records or one-to-many records, for example. In a backend point of view, so to know which models are loaded in the POS, we have the method load post data models that are simply the names of the models. This is used by these two data fields. That is where we actually specify which fields we want to load from which model. So these methods need to be overridden in the model in the backend to send back to return an array with the field names. I'll just quickly show. Sorry. No, it's not load post data fields. I'll remove these ones. And for example, here for account move, we're this is another way, only loading ID and name. Yeah, ID is always loaded, but we specify each time the field name. Then we need to know which domain we need to load. So here for domain, there is also another method that needs to be overridden in the corresponding model in the backend. So for example, here we only load the records which the names are equal to post settled due. Keep in mind that data is an array with all the data that is going to be sent to the front end, which means that we can access the data of the previous loaded models, and it's always in the order in which they are in the declared in the load post data models. So to have an example, here we have what is returned by the fields. So here we have the fields and their relation, but this is computed. It doesn't need to be specified. So for example, here do we have a relation? No. In the post config, we should have some relation. So if there is an empty array, it means it's loading all the fields. And can we see? Well, we have the name of the field, the type, and everything. And sometimes, if we find a related, it will say the relation to the records here. So it's a relation, the relation table, and the type of the relation. So this is needed for the front end to compute the relations. We also have custom fields that are fields that can be added to the data that is sent to the front end. So what data is sent is basically the result of the search with the name of the model. So here you have all the records. And if we need a field that needs to be computed in the backend, but we don't want the data in the front end for it to be computed in the front end, then we can simply add it. So override this method and add it in the record with an underscore at the beginning of the name of the attribute. Keep in mind that in the front end you will be able to access it but not modify it. So for a front-end point of view, for the loading of data, everything is made automatically. So the relation are computed. So records that have records. I mean, relation with records. This relation is computed automatically. But if you want to add some attributes to this record, or some methods, you can always create the class with your model name. Here I used post model, but it can be a post config or anything, and just add an attribute. But if you don't need to add anything, no need to create this class. It will be created automatically. And we have also different behavior for dynamic models that are models that can be created in the front end, and when you declare them in this getter, they'll be synchronized with the IndexedDB and everything. In a sense, you can create, for example, for an order, if we create an order in the front end, we don't have its ID, but to keep a record of it, dynamic models, what does it do? It creates a UID for it in the front end, and once it goes to the backend, it will have an ID. So the main point of related models is how do we access the data in the front end. So what we try to do is mimic the backend with the same field names and common methods. How is it structured? So we have two files, data service.js, that is a service that acts like it's initiating the related models. It calls the methods, the two methods here, data params and load data, to get the information, and then it will create an IndexedDB with all the information. And when this IndexedDB is created, it will create related models that will create the related models, as we can call them. So what create related models do, it will create a class models for all the model in general, and we can see a little bit models like the env in the backend. The object models will create an instance of model for every model that we want to load in the front end. So here, for example, we have models, the object that try to access to the model post printer, and if we try to get all the records. We'll see later all the getters we have. It will return a class base as we see previously. And these classes are declared in the index.js file. So how to access data in the front end? So we have CRUD methods, so create, update, delete. We have also get, that will get a record by its ID. Get all, that will return an array with all the records. Get first, that will return the first record. And also get by, that is a little bit special. It needs to be, it allows us to get a record by another attribute, another index. Oh, again. So database index, for example. Index, yeah. So here, it's declared here. So we can get post order by UID or a REST partner by its barcodes. So we only we can do get by here, for example, an order by UID, and then we specify the UID. So here we have examples. We create values. We get everything, and we can get an order by its UID. And we have more common methods like map on every record of that model, reduce on every record of that model for each record of the model, filter, length, and many more. Everything, every method can be found in the index.js. There are methods that are implemented in the model class. We also made back references that is acting kind of a getter, so they're not directly computed, but when you ask for the first time, it will compute it. So here, the purpose is, in the example here, we can see that we want to find so the tables doesn't have the order, but we want to see which table, which order there is on a table, and so calling backlink, it prevents us to search on all the order for the table. We can just look for the table and find all the orders. Another thing that is good to mention is that we keep the row of every object. It can happen that for some reason when we send, so it can happen that there is not the records available to create a relation. So if we try to access the relation in the front end, we won't have any record, but there is actually one. It's not loaded in the front end. You can always retrieve the ID in the row. It's a little bit, yeah. Keep in mind just the row, the content of the data that is sent from the backend is still in the row, even if it's not in the record in front end. And also to load data, we have so when do we have to load data? Is, for example, we do a call in the backend, and then we we do a call in the backend. We have some information. We want this information to be loaded in the related data, and we call either load connect data or connect new data, depending on the situation we have. So I'll do a quick example of what I'm saying. So here, for example, we have the service post model that is accessible every time. So we have our object models, and for example, we want to get. Let's see if you see. I'll probably. Oh. So I'll do, for example, for post config. Obviously, I need to. I'm messing it up. Okay. That, and I want to get the first one. There is only one, but get the first one. So I have my object right here. So I have the raw object with all the data from the backend. And when there is a relation, we only have the corresponding IDs. But if we go to relations, then we have directly access to the records linked to them. And this means that, for example, if I want to do this, I want to access the available preset IDs. I can access it directly, and I'll have them over here. Then we did someone for our team, Stefan, made a beautiful formatter for objects. So that we just saw here, because basically our objects are proxy, and when we try to do the same thing, it's really annoying to. I mean, it shows the base object, and yeah, it's a little bit annoying to see it. So how we do this? We just need to be in debug mode, and also, we need to allow custom formatters. So how it's explained here. So we go from here to more presentable way. And a little bonus. So with these related models, we limited data loading, where now we have an index DB in the front end. So if whenever we open a session, we will try to find which record have changed from the backend with its write date, and only send those one. We also, since we have the IndexedDB, if a user only reloads and doesn't close the post session, it won't send the data back, since it's already in the IndexedDB. So full data is only loaded first time if there is no IndexedDB available. And we also add dirty attributes in the base model. This attribute is changed whenever we change something in a model, and when we will we only send the dirty records to the backend. But again, this is all things. It's just for information. So yeah, final words. We managed to minimize coding errors since we have the same fields as in the backend. We don't process anymore the relation in the front end. This made coding faster, since it's more. We declare what we want. We'll have it in the front end. And overall, we have a stronger reliability. And also, bonus point with IndexedDB, we have kind of a PWA, since all data is stored in an IndexedDB in the front end. So yeah, that's all. Thank you for listening to me. And yeah, let's go to the questions. Thank you.
Need to be installed. Okay. Sorry.
Yeah.
So the first question is: are those custom formatters need to be installed before activating them via checkbox?
Those needs to be installed. No, so it's in the code base. You only need to be in debug mode, and yeah, you need obviously to accept to have custom formatters.
Will this affect the functionality of the offline mode of POS?
Yes, of course. So the point of sale is more usable offline. In a sense, since all payments and everything, and the payment can be processed because you need an internet connection. But let's imagine someone has a restaurant and it has, I mean, a zone where there is no internet. It can still take the orders, and when it comes back online, it will send the order to the backend. So it's usable but with limited functionalities.
And the last question: all these methods and model classes can work from any components, not point of sales only?
No, so it's only component. It's only for point of sale for the moment. I know there is teams that are interested for the, I mean, for the related models, but for the moment it's only for the point of sale.
Okay. We don't
Okay.
have time for the last question.
Okay, thank you very much. Thank you for everyone. Great.